Cook, thank you very much for bringing up early this morning, right? And I'm recording it because I understand many people could not show up here today. It's early in the morning and it's Thursday morning. So the fact that you guys found this place, that's a big deal. So kudos to you for just showing up. So thank you very much. So today we're going to be discussing about how to connect HMI to integrate that with Kinetic. That's the whole premise of this discussion. I also want to welcome everybody who has come here to support me and people. There are some of you who are more familiar with the background of the company and stuff, so please be able to chime in. So I also like to give some premise. I understand this is a mixed group, so many people may not know what the expansion of HMI means. So let me try to clarify that. If you're familiar with factory floor automation, if you walk around the factory floor, you will find machines, right? Machines that are pretty automated machines to do different things. On those machines on the side, you will find a small screen that is meant for controlling those machines. You'll find something that start the button, stop something, whatever. That screen is called HMI. It literally means human-machine interface, right? So helping both. Thank you. Thank you. All right. Can everybody hear me?
Yeah.
All right. I wonder if this is better on the third that. Anyway, if it's loud, I'll try to reduce the sound. So I was talking about HMI. Human-machine interface is basically meant for connecting the machines to the human beings, that the interface that is used by people on the factory floor. Right? That's the HMI. HMI effectively is a computer in itself. Right? You can program these HMI to control something called PLC, programmable logic controllers. So when you say in factory floor, if you have a machine that does something, let's say this is starting a motor, right? It is programmed by something called PLC, programmable logic controllers. So PLCs are controlled generally by HMIs. And the whole purpose of that is the kind of thing most of these automation engineers understand. The majority of people who are building automation for factory floor, they understand the ecosystem of HMIs and how to talk to different devices and those things, right? The ERP on the other side lives in a different mode, which is in most of the companies, you will find that HMI is in one network and HMI and the entire factory floor automation stays in one network, and the IT side of things stays in a different network, right? So that's usually the case. So we're going to be uncovering a little bit more details around that, and this will be quite a bit of technical in nature. If you do not understand it, do not hesitate. I'm happy to explain. Ask me to pause and I'm happy to explain. But I will try to cover within the time we have as much as I can. Right? Okay, so what are we going to be discussing about? The context of why we all started this journey. What did we wanted to accomplish? Right? Started with the business context, the challenge that we found we are looking to solve, and how did we solve this problem? The basic context of what we're going to be delving into the technical architecture of the solution, which explains the connectivity, whatever mechanism that we used. Then we'll be going into some of the ERP configuration that needed to make it happen. And finally, we'll also talk about the bridge application that we will be using for this. Remember, this is not about any add-on technologies. This is about, you'll be using the core Epicor functionality to connect to HMIs. HMIs is something, the hardware that you'll have to buy anyway, right? That's all it is. So we'll talk about this. This is what we're going to be discussing. So let's talk about the business context. Why did we do this? Okay, who is the company? What is the context of this company? So the company is called Filtration Systems, and this is based in Milwaukee, Wisconsin, founded in 1980, and Waukesha, Wisconsin. If you don't know how to spell that or pronounce it, I understand that. But so what do they make? Let's talk about the products, right? This is what they make. there is engineer managers here and a few others who are well experts with this technology, with the product, so I will let them speak if you guys are interested in learning about each of the details of the product. But the product that we are primarily interested in talking about is this air panel and cabin filters, this product, right? What is the challenge? So how do we make this product is on a cell. So let's look at that cell here. So if you look at that cell, what you're looking at here, this is a press. This is the press that is used for making this panel. That's what you see there. You put the panel in between and press that thing on the top, and that makes one of those products, right? You're effectively trying to understand how many of them we made. The question is, why are we doing this? The context is we are trying to measure the productivity, measure how many of them. This is primarily what you want from the factory floor. How many was made? When was it made? Who made it? Why did something went wrong? Why did it go wrong? That's the premise of what we are trying to understand from factory floor, information, right? So end of the day, what is it? So you can see the cell. So one side is this, and the other side, it's a different view of the same cell, how it looks like, and how people are operating. You can see it's a very small place. There is not a lot of space for people to walk around. This is literally what you would find in most of the factory floor environment. It's very different from the cubicles that you guys all work with. So it's a very different environment. So exactly what are we solving? Data collection. That's all it is. We are trying to collect the information, collect the data from the factory floor without affecting their operations. Right? So why do we do this? We want to give some real-time feedback. Real-time feedback, what does that even mean? For the factory people to be able to work properly, they need to see, they need to be able to see this live in action. How many did we make this? How well are we doing? It will automatically help synchronize the line or help people to adapt. That's information. So we need to be able to see the real time, how are we doing? At the same time, we also need to do diagnostics. We need to see, okay, how many did we make this week? How many did we do? What are we, so some diagnostic information. So you need to both these pieces of information to be actually useful. The entire premise of MES products is usually exactly this, right? So let's look at that. What are we doing? Data collection. So let's talk about the environment and some of the considerations that we need to address. So manual data, of course, in most of the places where they do such things, they would usually have somebody standing there with a clipboard and a clicker. Okay, how much time is it taking? How many did he make, right? That's usually how you collect the data. I can see some of you nodding your heads. So, this is the thing. This is, you saw the space earlier, right? How cramped that place is. You don't have a lot of place for somebody to stand there and click, and it's not even practical for somebody to collect this information. So they already have invested in Epicor and MES. So that's already there, right? Let's look at the market conditions. Everybody wants to increase their, the demand is going up and they need to increase the volume. Heat press cell, because this is a manual activity. Everything else can be automated. You still have to press it, and until you press it, you cannot make it. So it is if it has to function as a cell, it is a non-constraint in the process of what, if you are familiar with the concept of theory of constraints and bottlenecks, you will understand that this is, this is kind of in the same realm of the ideas. I'm happy to explain if you guys are unfamiliar with that terms or things like that. So, what is the solution? Solution is, of course, it all comes down to automation, right? What are we trying to? We will try to automate data entry, and of course, we are using HMIs in the factory floor. What if we could do a little bit more of that, right? And then integrate that with Epicor, right? Epicor already has ERP. Kinetic is a fantastic ERP which has connectivity mechanisms that are very, very useful and effective. So let's talk about the technical solution. What exactly is the technical solution, right? I alluded this to you earlier. OT network is what you would call as operational technology, or what is generally used in the factory floor technology and all the connectivity and everything else there. IT network is where your ERP lives, right? All your demand planning or your procurement, all the other office people work in IT network, whereas the factory people work in the OT network. You can think of it that logical. They are usually separated by that one line. The whole purpose of that line is that you don't want the OT processes affected by let's say cybersecurity issue, right? That's by design. Many people do it that way, right? So let's look at now. We have 6 presses. Right? These are physical presses that we saw earlier, right? One of them, and we will connect to that into a relay box. For those who do not know what a relay is nothing but a magnetic switch. You power it, and it will turn on something, right? You give it so you connect all of these things into a physical connection, into a box, and that connects, every time a press is made, it will close a loop, which gives you a connection. That's as simple as that. So it's a box. I just use that to explain that where you can, anytime you press, it connects. It completes the circuit, which means connects. It records that there was one filter that's being made. Right? That's all it is. So each of as they press it, the relay box provides this information to this HMI. HMI is what controls, or rather accumulates this data, and then go to the next step. So the Epicor is on the other side of the puzzle. This is on-premise, but it will work perfectly well even for cloud. There is absolutely no difference in this mechanism. So Epicor ERP is connected over Wi-Fi, and we all familiar with REST API. If you're not, you should go to Jose's class, or he was doing some of those into about how to connect to REST, but I will get into some of the details. So effectively, what we have here is a box that sits between these two networks, right? So you have one side we have in the OT network, and the other side we have on the IT network, and this is completely isolated, right? This IT net, when I say OT network, all it has on the other side is the HMI. It has which is connected to a physical connection, the LAN connectivity, which is called the RJ45, and then in this box you have something called the SQL Server Desktop Edition, which is a very small and free Microsoft SQL Server database, and you're running Windows on it, and we are running our Epicor client on this. So this is where you're running both your a small database and our bridge application that talks to the Epicor, right? That's roughly in a high level net architecture is exactly this. So the relay box provides the information. HMI collects that and writes into a SQL server because it has connectivity over the physical network. And the SQL server, there is a bridge application that reads this and puts it into Epicor. That's it. At the very high level, this is the architecture. Let's delve a little bit more into the technical details, right? So this is how, in HMI, this is how you are, this is the program from HMI to write into your SQL Server database. Or we're using this WinTech HMI, which is provided by Maple Systems. And that on the thing on the screen on the top, that is what is HMI is. One on the bottom, I'm sure you will all recognize this is the Epicor's client. So it's all in a giant, it's in a box, and it connects into this. Behind this monitor, there is a small machine, a Windows computer called a NUC, if you guys know Intel's NUC. You can substitute with any of these smaller computers that can run it. So effectively, you're talking about an Epicor client, and then talking to the HMI. So this code here, all it's doing is on press of a button, write it into a SQL Server Desktop Edition database, right? That's all it is. And what is it doing? It's writing into this press cycle counts. It will come in a second part. So now let's talk about, that's the configuration, that's the HMI side of configuration. We're done with that. Now let's talk about what we do in the ERP side of things. To make it happen in ERP, we need to start with defining what are the resource groups that we're dealing with. So this is the screen for getting into resource groups. This is the classic screens, but you will absolutely find the same equivalent thing on the Kinetic too. Because just show this because this is the fastest and easiest way to get it. So at the end of the day, what you need is creating a resource group. You need to create a resource group. Then you need to create, define your plan about, what is the labor hours and blah, blah, blah. And after this, you're going to be defining your production activity. So you're going to be defining your production activity that explains. So these are all different screens. You just go to the first step, which is define your groups, define your plan, then you define your production activity. And after this, you will be defining according to this production activity, day one, which days are these production activities going to happen. So this completes your configuration on the Epicor ERP side of things. Would you like me to pause and anybody has questions right now? Yes?
Where are you defining that plan?
This is defined in Epicor.
Where?
If you go to the, you'll find the screen. Just give me a second. You'll find the menu item for plan in Epicor's screens. You search for the Epicor
Resource group or?
No, you'll just find it in the plan. You'll search for the menu items, you'll find it. Search for, that's exactly what I gave the, search for this term, resource groups, you'll find the resource group screen that will help you create one. Go to the search for the plan screen, you'll find, the plan screen looks exactly like this. When you create a plan, then you create your plan detail, which goes into production activity. Then you create your production activity, then you have defining which days is affected. And this is kind of the setup you would do even for advanced MES. That's usually what they do, right? This is not advanced MES. This is the gateway towards advanced MES, right? So let me be absolutely clear. This is nowhere close to what advanced MES. That's the best, much better product. If you have the budget to do it, please do it, right? If you don't, then this is meant for people who do not want or do not have the money to go in this route, right? So this is the cheaper solution, but it works. That's what it is. It gets you started in that route. So that's the objective of it. So now let's talk about, we completed the HMI configuration, we completed the ERP configuration. Now we need to talk about the bridge application. So let's talk about that. I'm going to skip talking about Rust APIs. Rust is, but give you the high levels, those who are unfamiliar with Rust APIs. This is an amazing, technology, or rather a feature of Epicor ERP, Epicor's, Kinetic ERP and others, which allows you to integrate with your ERP. All you're doing is you can create using an HTTP endpoint, create an API key, and you will be able to talk to your ERP easily. So we will be using a bridge application. Now you need to know how to talk to it. You need to obviously query the database that you created, your SQL Server Desktop Edition database. So these two tables is what is important. So it is production activities and production activity detail. So this is all you need. Now the code you're going to see is in Python. This is not the standard of C# and other things that are in Epicor's environment, but it's simple. It is cheap and it works for people who are uninitialized, or you don't have to deal with a lot of complexities that you would need to worry about. So this is it. So in Python, you will define very simple in production activity. So imagine this. So when I press of a button, it writes a record. Right? That record is in a SQL Server database. You read the SQL Server database and then call the REST API with a structure that looks like this. Right? The company, define your company. Your plan ID. This is the plan ID that we created in the previous configuration screen. Right? So we have hard-coded that component. You're welcome to play around with the different approaches, but this was the fastest and the cheapest way to get it done. Right? That has been our approach. So get this done. Then we're talking about descriptions. Of course, you have in Epicor, you have the capability to add UD fields or extend the capabilities of it. But we started with the core and the basic functionality and trying to cram that into it, and that is why we are using this dash resource ID as an approach. But it works, right? And then you define your resource group ID, your resource ID, and the date that's coming from your thing. At the end of the day, you will be calling this BO, business object, that is ERP, BO, production activities. Behind the scenes, it's calling the full endpoint with your interface name, and that's it. So with that, all it's doing at the last line is sending this data that JSON data that we just created into in ERP. After that, you go to create a production detail. Production activity detail is where you define your company, which activity ID. So when you create this production activity, it gives you an activity ID. So against that activity ID, you will have to create a production activity detail. So this is 2 steps process to get this activity detail into the print. One complexity here is this end time. You will see in the next screen how that is a little, it's a quirky way of doing it, because that time is derived in a certain way. We'll see that. It is based on, it's a pretty standard sequence, but it's not so difficult to accomplish if you understand the structure of how it's laid out. So with that, let me get into that. The last line again is just, here is the production activity, the other one is production activity detail. Yes, question?
Is this synchronous or asynchronous?
Synchronous.
Is this sending in real time or is this batching and sending?
It is batching.
Okay.
Right. So there's no point in coming every. You could, but it is more effective to just run it in 10 minutes. That's acceptable. So every 10 minutes, there is a program this batch program that will read from here. SQL Server database. SQL Server database is continuously updated. Your Express Edition database, and from there, the bridge program is running continuously, but every 10 minutes it pulls the data and ships it into Epicor. All right, thank you, good question. All right, moving on. So, okay, we did all this work. We want to see the results. How do we see it? So here you can see production activity tracker. Earlier somebody was asking, how do you get to this? This is the menu option. You can find search for a menu. That's how I always find it, because there are a billion menus in the Epicor's structure. So I always try to search for it. That's a much faster mechanism to get to the menu. So I search for the production activity tracker. You will find production activity tracker. And then you can search for the resource ID that you're interested in. You can search by all of these parameters. Plan ID, these are all the things that you gave in your previous structure. With that, you will be able to see reports like this. You can see here, that is what I was saying earlier, that the production activity is recorded with this kind of a number. It's hard to see, but you see this 025032535. That's how internally that records. Right? If you're using advanced MES, that translates all of these things. Because we are not using it, we have to define some of these things. But it works, right? If you export this data out into an Excel and try to manage it, you will find it. And if you want, you can add another translation tables to make exactly what you do. It will give you, when was this production, when was this activity happening? Ignore the first one, just as an error record, but yes, that also happens. Otherwise, the rest of the records, you can see it in a 3D view, how the activity has been happening. You can correlate that, okay, 025 corresponds to 2 o'clock in the morning, 2 afternoon when the people on the factory floor went out for a smoke, right? So this happens, right? So bottom line is, you can understand what was happening, how much activity was happening, who was working at the time, and you can correlate with other data that's available in Epicor. Right? So that's the bottom line of what you're trying to say. That's not it. That's the one last thing is the production activity summary. Now we are seeing an activity detail here, right, for each of them. Now let's look at it from what happened in the week. How many did we make over the week? How many did we make over the month? Right? All of those things are possible using the summary. We can now summarize it. Now you can aggregate it. Now you can really understand we will accomplish. So from the beginning, what did we try to accomplish? We tried to accomplish aggregation. We try to get it into Epicor's structure of how the production activity is maintained. Effectively, we came to a point where we can realize how we can understand a lot more in terms of granular details about how the production activity is happening, what are the parameters that are driving it, and possibly correlate with and understand it a lot better, right? So this is all built into Epicor, and you don't really need, these are all standard forms. You don't really need to invest in any third-party solutions or for screens or anything of it. This is why I said earlier that if you try to add UD tables and stuff, you will end up having to customize this too. Of course you can do that too, but that requires more effort. So it is, if you are trying to accomplish something on, pennies or dice or whatever, then yes, this is a solution for you. Yes.
When you report the production activity this way, is it also reporting like the operation finished good, or is that you still have to do like report when at the end activity?
How many, you mean, how
Like,
many?
like actual production quantities.
Yes, that's exactly what you're seeing here.
Right, I'm just wondering, is that translating to like labor detail production quantity reporting
On MES stream.
Yeah,
They are not connected. They could be. But you could use that as a validation, right? The problem is, in the factory floor, they are not using MES and they're not telling how many they made.
Oh, they're not.
This is supplementing that process.
Okay.
You're absolutely right. If you are using MES on the floor, they will be telling, I made this. That means they have to do one, for every product. Sometimes these orders, they're not receiving in one order each. They are receiving 200 of them, or, so some of these orders will run for a week. So, which means that they will be starting an activity a week before, and then they'll be acting, you'll have to wait till the end of the operation cycle to understand it. Did that answer your question?
Yeah, I'm just more curious on the costing side, right? Because
Yes.
we clock into the job to record costs,
Correct.
right? And so we want to know how long did it take to produce this one pallet, right,
Right.
of reported quantity.
Right.
So I was just wondering if that was related or just two separate things. And I mean, we could use those numbers to
Correct.
feed either one.
I was just about to say that. Now you have the collected information that is automatically collected. It's a simple BPM call or something on a functions to get this data into it, right? That I don't have to tell you guys. Yes.
How we can connect this data to a job actually? We need to see by a job.
Yes.
Or further detail maybe by an operator.
Correct.
To see like how MES does.
Yes.
Is there a way through this HMI device we can get the job number input?
It can be done, but we have not done it. Because it can be done, because remember, HMI is a very functional device. It can be, you can connect that into a scanner, and it can connect into give it a job number. But then you run into the same problem, right? If you are trying to do certain number of jobs, and it is fully every job, then that logic absolutely makes sense, right? It's your case. But if you are talking about batches and larger quantities, then you need to have, so then you're dealing with a different problem, which means that the job doesn't get over, you don't get that information until the job and operation is completed, right? So yes, it is possible. When you scan the job, it is possible, but for this application, we did not do it. We can store it into a UD table if we need to for every operation because we are collecting it, right? So this is the job that we're running in. Scan it, collect that into that, put it into the SQL Server database. Because we have a full database on our disposal. And from there, you do whatever you want. You have full control over whatever you want with it. Because we have the bridge application, you can correlate that with the current job that is running. All of those things are possible. Yes.
Do you integrate maintenance alerts into Epicor? So one press might do 10,000 units and then require 10 hours of downtime to be repaired. Is that alertable?
Sorry, can you repeat the question, please?
So one press does 10,000 units and requires 10 hours of maintenance.
Right.
Those alerts can come out of Epicor and be automated?
It can be, but that's not a part of the scope of this.
Okay.
That is because we're talking about the production maintenance kind of thing. If, okay, how many cycles did it take? It's in a complete, that is why you need advanced MES, right? That deals with a lot more other than this. This is just very basic production activity. And that's all it does. It is not doing any of the other things that a typical MES system will do. So for that, please talk to your team. They are the right people who can guide you to, if you are having those use cases, please, that's the better approach. This is more scaled down. Maybe this is the startup steps towards that. Many people are concerned about, if you talk to advanced MES folks, what happens is usually the price is a big factor, right? So this gets you started. But once you start seeing the value, I am certain that you will want to do more, right? You would want to connect a lot more. And that's when you can start saying, okay, all right, so you already have it all configured. All you need to do is build the right approach and then connect them together. Yes.
So one day we could reach to a level that we can replace MES through this?
No,
automated?
MES is different. MES has a completely different process.
Like the user input, like in the job, time,
Yes.
operator,
Yes.
the start time, end time.
Yes.
I mean, can we get this through automatically without the user input?
That's exactly what we are trying to do here. Start time, end time, we can get here. What we are not going to get is OEE, like he was explaining about production, how frequently does your machine goes down. right? Like your typical OEE counters and all of those things are usually done in a more MES cycle, right? That is meant for the MES. I understand in Epicor MES process, that is just start the activity, end the activity. That's all it is. That you can accomplish with this. Okay, so if that's all your objective is, yes, you can.
And
But-
we can capture the operator or the
Yes.
machine or the resource ideas
Yes.
from here.
Yes. If that's all you want, yes, you can accomplish to a certain extent, right? It doesn't count your labor hours fully, data collection process, which is what Epicor MES is. It has a lot more other features, right? If, for example, attendance, there is a whole bunch of other things. You look in the MES forms, you'll find, tons of things. But it is, so that's the value of MES. This is a scaled down version. It will give you some things, right? It will get you started. It's not a full solution, but it will give you, most of the cases, the driver for this is how many did we make, right? They want to understand the production activity. That's what we're trying to solve here.
Exactly, that's what I meant actually. MES, I'm talking about the production activity.
Yes.
That's the main focus.
Yes,
Exactly.
yes, yes.
So like before you implemented this and after, how much of a closure in the data gap did you see?
We have not completely measured it yet, which is pretty new. So I don't have that information right now.
You're seeing
we're still
some
collecting.
results though?
I'm sorry?
You're seeing some results though?
Oh yeah, of course, of course. So there is two parts to that problem, right? The question is, so there is I said earlier that this data collection has, one is the real-time impact. A real-time, we can see, okay, how many did we make yesterday, or not yesterday, rather, how many did we make today? So the impact is on the floor employees itself. They can see, oh, today it's looking like we made only 45, so I better not take that break I was planning to do. So, you're in real time controlling behavior on the floor. It's very different from, so you're trying to control both. So diagnostic information, we may not have it, but there is clearly benefit. We don't have it fully recorded yet, it's pretty new. We're still trying to collect information. But on the surface, I can clearly see there is benefit in terms of just the communication, right, on the floor. There is that aspect as well as the collection information aspect. So considering that, that's what I thought it would be a very, yes.
Do you have any plans with this to bring any data back, bi-directionally at any point, or show any metrics like to the user, like they can see their stats, like how many they made today or anything?
We're showing them live.
I didn't see that part.
Oh, so here, let me see, here, on this screen, on the top here, we are seeing which
Oh,
press
okay.
and how many did they make.
I got you.
So this is what I was saying about having this information live shown. It itself is valuable. This is what she's showing in HMI. This is not coming from Epicor. This is coming from what HMI has recorded in there, right? That activity. This information gets recorded automatically into Epicor because of the reach.
Okay, so you answered the second part of my question. First part was, is there any information that you are planning on bringing back from Epicor at any point into this simple interface?
At this moment, I'm not sure yet because we have to see that, like someone was asking earlier, right? We need to see the real data. The direction will be depending upon what we're going to be really seeing. Is it worth? At this moment, I do not know. It may be there is a use case. As we determine, we will collect
You haven't
information.
come across one yet?
No, I haven't come across one yet. If you guys have ideas, please talk to me. I would love that. Right. So with that, where are we? So this is the result. And so let me summarize it here, right? Number 1, 2, 3, very simple. If you don't remember anything, just remember this. PLCs and HMIs sounds like big buzzwords, but it is not so difficult. You guys deal with Epicor and all the complexities that deals with Epicor. This is not so difficult. People on the automation floor, they make you believe that this is huge, I can't do it, we don't have time. Just get into it, right? You can do it. Just get into it, search for it, and there is enough help available. You can actually do some work that I showed you earlier, right? The PLCs can be programmed by people who understand the logic flow, and at least that's, I'm expecting everyone here will understand that. So a bit of technical expertise is needed, but it can be done. You don't need to know everything, but it can be accomplished. The second part is, ERP has some advanced capabilities. Before you start finding the adapters or finding the third-party tools, look at least utilizing everything that you have. How much can you bring without using that, right? That's the second part of the thing. The last part I would suggest, and probably the most important one, I should have put it at number one, start with why do you want to solve this, right? So start with what is the problem. Don't start with, sounds cool, let's do it. No, let's start with why do you want to do this? Let's say, do we want to count the production activity? Why? Is it helping? How is it affecting? So start with that question first, and then you figure out how do we do this, all right? So I would leave it with that thought about start with the question of how does it solve what business problem you're trying to solve, and here is a technology. If you believe this technology, this could work for you. I think that's what I would posit. Is there anything else I can answer? Anyway. Okay. Yes.
I like that last piece. Sometimes we like to take a technology and say like, well, this needs to be put here because that looks
cool.
good, or I can get the technology to work. And you get the technology to work, and everybody's like, look what we did.
Yes.
And then
yes.
they don't even relate it to the business problem that it was solved.
Correct.
Like
Yeah.
you were asking, are you seeing results?
Yeah.
Is it helping them do their job? Are they
Yes.
seeing, is a supervisor keying into these HMI metrics, to be able to help their
Yes.
people out when they're sort of slow, there's some
Yes.
problems. So that's cool. Yeah.
Exactly right. And in fact, we are going. It is not that screen that you saw. It is not about for supervisors.
Sure.
It is for the people on the line. They will be able to see that how many is we making, right? And this will self-correct that. And without that data, maybe we are losing time. Maybe we're not getting the full productivity. But you don't know, and they will not tell you. And if you ask them, they will come up with 5 different excuses, right? Yes. Yes.
Did you do the ladder logic that you were showing?
I did not do it. I had a more expert person doing that. But I can do it. I mean, once I look at it, I think next time I need it, I will do it. No problem. Yes.
What's the evolution of your system from this point? What's the next step, do you think?
Next step is obviously looking at the data. Looking at did we actually accomplish what we're trying to do? I think we should. We have to collect this information, and then the next probably would be, like you pointed out, possibly expand beyond this, right? Possibly look at integrating that with MES components a little bit, or even production schedule. Now you know how many are they making, right? Even PM schedule and stuff like that. There are so many other places.
Or QA.
Yeah,
They
of course.
produce X, but what are good?
Correct. Right.
We're looking into something similar to this for QA purposes.
Uh-huh.
And I don't think we're at MATEC level, but someday we might, so this is interesting.
Yeah.
Right.
Yeah, Deep.
Did you consider using I haven't tested or played with it, but the Epicor IoT interface at all?
Yes, I have. But here's the problem. Epicor IoT interface is fantastic, but the production people, they like that. Right? The automation people, if you talk to them, they like the field bus and ladder logic. End of the day, you're talking to people who understand how to build machines. So we need to be able to understand their language, right? As opposed to, I could have built the same thing using a ESP32 and a screen, right? I'm certain that we could do it much cheaper in terms of cost, maybe $20, $100 less, right? And plus, we will have to build a screen, and then you have to build a box and all these things. But yes, you can do it with that kind of interface. With a microcontroller, you could add the screen. But then that's what would be building an HMI, right? So best thing is to leverage what people already have. If you can find a way to talk to them, that is more effective, and you can leverage those automation resources more effectively. That was what my point. Yes.
So you're recording the data from the resource that they're using,
Yes.
whether it's a press or whatever it is.
Yes.
And then MES, I saw you had side by side. It's not on the machine, the MES screen. It's on maybe a computer somewhere apart from the machine, right?
It is on that machine, that bridge machine, the same place.
Okay, so the HMI is on the same,
Okay, so
Physical.
here, HMI.
there you go. Yeah.
HMI is on a different box,
Okay, yeah, above it. Okay.
above it, right above that.
Great.
Right? The bottom portion is the, your standard MES and your those.
Yeah, and that's what, like we talk about a progression of an HMI, how much do you wanna complicate it, like you said, to the extent that you take away from the operator's ability to use the machine to make the stuff they're making, whatever
Right.
it is. I'm trying to find that balance of like, well, we would need them to clock into the job. It would be nice to control the HMI in that regard, like push that schedule, like you said, to
Yep.
that production schedule to the resource and have them choose from that before they can even start the machine.
Right.
That way you can relate the data transactionally to that timing piece. But
Absolutely.
yeah, to start where you're starting is
Correct.
great,
Yeah. So, like I said, right, depending upon your environment, you need to see what's the right fit. It could be, I cannot tell you that this is the next step or this is what I want to do, because I need to see, properly evaluate how did it impact. Did it actually? I believe it should, and I can see all the evidence that it is right now, but we are still collecting. Then, and depending on that, we'll determine what would be the next step. But you're right, all the ideas that came about is absolutely valid. QC is an excellent one, yes.
Yeah.
Did you use a single relay aggregator for all the machines, or do you have one relay per machine?
One relay for each machine.
Okay.
Each relay closes the circuit, which turns into one dip, or one cycle.
And do you ever have conflicts if two machines are pressed at the same time and the data coming in?
Doesn't matter, for each of them are individual, so end up
They have their own
talking
ID.
about one byte.
Okay.
So each six pins, that's all.
No conflict.
No, they are all individual, that's why we have parallel lines across all of them.
Okay.
And they're all in the same cycles. When I say parallel like, it's just one cable that goes over there. That's it. One line, and comes back in, and anytime this is a press, it counts as one cycle. And you will get a byte. And that byte is what you're going to be reading. It's actually the HMI does most of this work anyway.
Yeah.
So HMI will write that into SQL Server. For as far as the bridge application is concerned, we'll read from a SQL Server and write it. SQL Server has the details on which was pressed, when was it pressed.
And a follow-up question, what was your time of implementation for this solution?
This took us about 3 months. Start to finish, I think, yeah, roughly.
Like from concept to finished product on all six?
Yeah. And it took a longer to iron out all the details, but I would say 6 months or 3 months, maybe a little more. Yes.
Do you have standardized work that they're following when they go to start up the machine and use the machine?
You're
Yeah.
talking about SOP, standard operating procedure.
Yeah, like how conforming is your process to those SOPs? Like, how important is that for you? Have you found that, mixed procedures make it hard to understand the data? Like, say you start the machine, you do a cycle, maybe they don't follow the same procedure every time, so then the data is hard to understand. I don't know, how has that played in, if at all? Like, do you see the need to standardize your procedures more, or how they're doing their job, doing the parts?
SOP standardization, that is clearly within the realm of industrial engineers who will define that, right?
Sure, yeah.
So that's absolutely, it has to be, that is before all of these things.
Yeah,
So some of these inputs that we're collecting could lead to changes in that SOP, if that's what you're asking.
yeah,
right?
okay, yeah, just how's that helped, yeah.
Exactly.
Yeah, okay.
So now that you have more granular data, you can make intelligent decisions on what might be more reasonable, right? More effective approach to adjust the SOPs if we need to. All right. So with that, okay, I think we already covered the questions. So thank you very much, gentlemen.
We
And
have
ladies.
more questions.
You have more questions? I'm happy to answer any questions you have. So thank you very much for coming in.
Thank you.